This one feels like a p-series as I approach it. Unfortunately, the +3 throws this off, so we can't use a p-series. So I can't use geometric because I don't see a common ratio coming out of this. I don't see really any a constant to the n power. That's typically what you have when you have a geometric. Right, it's usually geometric is usually a sub 1 r to the n minus 1. So my exponent is n, a number, as n, a variable, as opposed to here I have 1/3, so that's no good. So unfortunately, this is one of my least favorite ones, which is the integral test, where I have to integrate this. So whenever I do the integral test, you want to rewrite it as a limit statement. B approaches infinity. And then wherever I see the n's, I'm going to write as an x. So that's the cube root of x plus 3. I'll put a dx on top. So then I will rewrite this as the lim as b goes to infinity of 1 to b x plus 3 to the negative 1/3 dx. And then I'm going to evaluate this integral, right? So I get the lim as b approaches infinity, so x plus 3 to the 2/3, 3/2, and then I have 1 to b. And then I have the limit as b approaches infinity of 3/2 b plus 3 to the 2/3 minus, plugging in 1 here, I get 3/2 4 to the 2/3. Well, this has a positive exponent, so this is a pretty big function, and if I plug in infinity, it's going to get even larger. So this is really just going to go to infinity. This thing over here is a constant. You subtract off a constant from infinity, it's still going to be infinite, so I'm not even going to write that what this term is equal to. I don't really care what that's equal to. So therefore, this is going to be divergent by the integral, I spelled that wrong, integral test. Okay, all I'm looking for here is that you replace all the n's with x's. You have a limit statement on every time until you plug in it, so therefore notice that there's no lim here because I didn't plug in infinity at this step. I plugged it really in between these two steps, so therefore the limit is gone. That's pretty much it. You're supposed to notice on integral test problems, you're supposed to say that the series decreases. I'm not too worried about that because that's not really going to show up on the AP exam since there's no multiple choice this year. But you're supposed to acknowledge that, but I've glossed over that because it's really not that important. Lastly, you need to write down divergent integral test. Notice that I didn't rewrite the problem down here in front of this statement. I'm good. That's enough. Okay.